An electric circuit is a complete path for electric current to flow from the negative terminal of the power supply through the components and back to the positive terminal of the power supply. The diagram below shows a power supply, in this case a battery, attached to wires, a switch, and a single bulb. However, because everybody draws differently and everybody's bulbs might look different, electricians use schematic diagrams with universal symbols that everybody knows. This is the symbol for the power supply, the battery. Then we have our switch, followed by the light bulb. All wires are drawn with straight lines and right angles. Let's build this circuit. First, we need a power supply, this 9-volt battery. Hook a wire to a switch, another wire leading to a light bulb, and a wire back to the battery. If the switch is closed, then there is a complete path back to the power supply and electrons flow through the circuit, lighting the light bulb. If the switch is open, if a wire is removed or a bulb is removed, then there's no longer a complete path and electrons stop flowing. Now let's build this circuit with actual components. The power supply is set to 6 volts. Run the first wire to a switch, next wire from the switch to a light bulb, and from the light bulb back to the power supply. When the switch is closed, electrons can flow and the light turns on. Same as before, if the switch is open, if a wire is disconnected, or a bulb is removed, there's no longer a complete path and electrons stop flowing. A voltmeter can be used to measure the voltage across a component. The red positive wire is placed closer to the positive terminal of the power supply. The voltage across the power supply is 9 volts. The voltage across the light bulb is also 9 volts. This is a multimeter. It can be set to measure voltage. The voltmeter is reading about 5.9 volts across the light bulb, a little less than the 6 volts from the power supply. Some energy is lost to the wires. An ammeter can be used to measure the current, or how fast the electrons are moving through the wire. The current in the circuit is 0.6 amps. The current is the same everywhere in this circuit. This multimeter can be set to measure current, but we must put the ammeter in line with the light bulb. To do this, we disconnect a wire, hook one lead from the ammeter there, hook the other one to the other wire. We can see the current in the wire is 0.14 amps. Objects can be described as either conductors or insulators. A conductor is a material that easily transfers electrical energy. An insulator is the opposite, a material that does not easily transfer electrical energy. We can test if a material is a conductor or an insulator by putting it into our circuit and seeing if electrons will flow through it. If they do, the light bulb will light and it's a conductor. We can put materials in this gap and see if electrons will flow through it. Here is a piece of copper. Here's a piece of rubber. Here's an iron nail. A piece of aluminum. A piece of paper. A piece of zinc. A piece of graphite. A piece of wood. And a piece of plastic. Here are all the materials that allowed current to flow through them and light the light bulb. On the right, we'll put all the materials that did not allow current to flow through them. The light bulb did not light. We can do the same experiment using a simulation. In addition to the materials we just tested, we can also test glass, brass, lead, silver, and yarn.